Welcome to another episode of Tractable. I'm your host, Kshitij, co-founder and CTO here at Orb. And today I'm really excited to have Kshitij on the podcast. Kshitij is the CTO of Honeycomb, and Honeycomb is a platform that helps you understand your application in production, sometimes called observability, but I'm sure we'll dive into that today. Honeycomb is used by orgs like Vanguard, Slack, and Intercom. And as many of you all know, Kshitij also writes and shares a bunch around engineering management and organizational design, in addition to technical topics. So we'll have a ton to talk about. Kshitij, welcome.
Thank you for having me. We've been trying to make this work for a while now.
Yes. I want to get into the meat of it. I know you have a ton of really well-formed thoughts at Honeycomb around observability or what the industry at broad calls observability. Let's just start with a core thesis that you all have, which is this difference between observability 1.0 and 2.0. So maybe you can give some context around what that means, and then we can dive into what the kind of precise differences are.
Yeah, for sure. So when we started talking about observability back in 2016, it was a way of differentiating between what we were trying to build and what the rest of the world was doing, which was very rooted in metrics, which have no context, and the monitoring sort of approach which works really well for systems that fail in predictable ways, which increasingly is not the systems that we're working on. And so at this point, I would say Observability 1.0 refers to tools that have many sources of truth. There's a famous definition that observability has three pillars: metrics, logs, and traces. Most people are paying for way more than three pillars. They've usually got RUM tools and APM tools and logging tools. Maybe they've got structured and unstructured logs, and they've got their SLO, and all of these tools, they're not connected. The only thing that connects them is the engineer who sits in the middle, visually going, that spike looks like that spike, and like maybe copy pasting IDs around from tool to tool. But you've got many sources of truth. Nothing ties them together, which means that you have to rely a lot on guessing and intuition and like past experience when debugging these systems. And Observability 2.0, it's a single source of truth. Arbitrarily wide, structured data blobs, logs, whatever you want to call them, events. But because there's one source of truth with all the shared context, you can derive metrics from them. You can derive traces from them by visualizing them over time. But it's all connected. And you as an engineer could go, here's my SLO. It's burning down at this rate. Here are the events that are violating the SLO. Here's how they're different from the events that are not violating the SLO. Like I was just talking to a customer of ours who's just started rolling out front-end observability, and they're going from this like weeks-long process of identifying latency problems, trying to repro them, literally weeks, has been reduced down to minutes. Because when that connective tissue is there, you can just ask the question. You can just see exactly what's happening. So much of debugging boils down to, here's the thing I care about. I might not know why I care about it. And in fact, most of the process of debugging is figuring out what's different about this thing that I care about versus everything else that I don't care about.
Yeah, that's interesting. I'm wondering, like, and you mentioned this a little bit, but what are some signs on the ground? So let's say I'm an IC engineer. What are some signs that my org is stuck in this like 1.0 style of thinking? No matter what tool I use, like, what does that look like
Yeah.
tactically?
The huge difference between 1.0 and 2.0 is also that observability 1.0 is very much about operating your code. And it's intrinsically reactive, right? And 2.0 is very much about how you develop your code. There's so much, I think of it as just like dark matter in software engineering. It's like, why? It doesn't seem like we should be moving this slow. Why are we moving so slow? Like you can't really put your finger on it because you can't see, and like when you have an observability 2.0 mindset and toolkit, you can see where that time is going. You can see exactly what's happening. And this is something, it's Plato's allegory of the cave, like trying to explain to a blind person who's lived in a cave their whole life what it's like. There's a bit of, look, you almost have to take it on faith that it is this different, because vendors have been lying through let's not say lying, but like exaggerating the impact of what they sell you from day one, right? And so there are very few things in software engineering that have actually had this kind of outsized impact. And in my experience, good observability tooling is one of them. Because we always talk as managers, directors especially, you're always looking at the feedback loops inside your organization, because these feedback loops amplify each other, right? And so if it takes you 15 minutes from the time that you write the code to deploy the code versus 2 hours. It's not actually an hour and 45 minutes worth of difference. It's way more than that because of the amplification effect of it. But in order to have those really tight feedback loops, you have to be able to move with incredible confidence. You have to be able to validate every single step of the way and quickly figure out if it's doing what you expected it to do, if anything else looks weird. And when all that they have are metrics and aggregates and exemplars, you fundamentally can't answer those questions with any actual specificity.
How much do you think the existing pattern is an artifact of maybe just like slower deploy cycles, or this idea that you package up your code into some binary, it goes out a month from now, and all you can collect is some like bare telemetry data? Is it just that pattern is still the style of thinking, and that with the sort of continuous release cycles, deploying to production many times a day or even every commit, that's the thing that is just we have not fully adapted to that change? Or is it some other reason why this 1.0 style of thinking is so tempting, or maybe even just prevalent?
Why is it so tempting or prevalent? I think my personal philosophy or theory is that it has a lot to do with the fact that we are embodied beings. And as mammals, like whenever we get scared, our instinct is to freeze and slow down and go, let me get control over things before we start up again. And that kind of instinct is just deadly in software, because in software, speed is safety. And a lot of it has to do with the fact that when you're writing code, as much as anyone will ever know about the thing you're trying to build, why you're doing it, how you're doing it, what you tried that worked, what you tried that didn't work, what the variables are named, what the functions are named, you have all mapped out. And how long does it last? An hour or two, maybe? Like, it certainly doesn't survive you paging in and out another project, let alone a month down the line. You're going to have to learn it all over again, right? And you're not going to learn it in the same way. Like, the shorter you can make it, like, ideally, you can have it in your head, instrument your code as you go, have it in your head, keep it in your head while you deploy, and then go and close the feedback loop by looking at that instrumentation that you just wrote and asking yourself, is it doing what I expect it to do? Does anything else look weird? That moment right there is your best shot. Like, there's been data that shows that the cost of finding and fixing bugs goes up exponentially from the moment that the bugs are written. You type a bug, you backspace it. Good for you, right? But finding it right after you put it into production, when you still have a clean baseline, right? It hasn't become the new baseline. That's your best chance of finding it if you still have all that context in your head. But all of these tiny little decisions all these little blockers, the little bits of friction and the drift and the test getting slower over time, all of these things conspire to make these things longer and longer. And then when we have problems, we slow down even more. And we're like, let's add a gate, let's add some approvals, let's add some more tests. When in fact, the most important thing you can do as a leader of software engineers, whether you're an IC or a manager, I don't care, is keep those feedback loops tight. And this is a really daunting thing when you're coming from the other side of things, right? But the good news is that every step you make towards shortening that feedback loop will also pay off. The feedback loop, it intensifies, it feeds upon itself. And it's not, I feel like it's really frustrating as an engineer or a manager who's trying to debug a software engineering culture and team that's just fucking broken, because it's broken in so many ways. And you're just like, you're distracted by all the symptoms and all the ways that it's broken. But I think that leaders just need to narrow their field to focus on that interval, right? Compress it, make it shorter, do whatever you can, because so many of these symptoms, you don't need to fight the symptoms. You need to fight the fire, and the fire is how slow everything is. And this is also something where I think that a lot of people have taken stabs at this and found it really frustrating and hard. And that's because good observability goes hand in glove with this. The more you can see what you're doing, the faster you can move. And the faster you can move, the better you can see what you're doing.
Yeah, it's interesting because I suspect that most organizations don't think of their observability tooling as necessarily a feedback loop. They just think of it as a debugging tool, right?
Exactly.
Which is, I'm imagining most engineers will go to Datadog or will go to even like their entry point is like PagerDuty to whatever observability tooling, because something is wrong, something is on fire. And I think in other places you frame this as like your relationship with production, right? And is it a relationship where you only look at it when you're stressed out and worried that something is actively breaking? How should that be reframed? Is it like what is the right time to be setting up the surfaces in your observability tooling where it's not just like something is actively affecting a customer?
I feel like we are right now in the early days of what I think of as observability driven development. I'm working in the
Hmm.
situation where TDD was like 15 years ago, where everything is super manual and by hand. It feels a little foreign. We got used to the idea that we didn't know if our code was working or not until the test passed. Not enough for it to compile or parse.
Right.
You need to know that the test passed. And I feel like that we're extending that right now, because in reality, you don't know if your code is working or not when the test pass. You know that it's probably mostly logically consistent. You know that you can
Yeah.
find the
Yeah.
bugs that you've already found in the past. You don't know if you've created any more bugs, and you don't know how users are going to use it. You don't know that
Yeah.
until you've watched it in production. I think that 2, 3, 5 years from now, there's going to be better tooling for this. It's not just going to be like close the loop by manually instrumenting and looking at it. But that's where we're at. And I think that this next sort of evolution was really kicked off when we started realizing that you have to put engineers on call for their own work. It's not, you
Mm.
can't just expect half of the engineers in the world to write the code and the other half to understand the code. Those have to like coexist in one mind. And so I feel like you get what I'm saying. I think that there's a lot of fear and dread around production systems, and I totally get it. As an operations engineer, I used to cause a lot of that fear and loathing. Get your ass out of my production system. It's a huge mistake, right? It's our job not to make people more afraid of production, because their job is ultimately production, but to find ways to welcome them into the fold and to make it safe for your curiosity, to make it safe for you to ask questions and explore. At the end of the day, we all want to do good work. We all want to make sure that the code that we write gets used. And you can't do that unless you are intimately familiar with production.
Yeah, it's. I think you've written something about this, but I don't remember where you landed on this. But one problem that I see a lot is that is related to how things are performing in production. Is product engineers will architect a feature, write this data model, and then the infra team, infamous infra team, will be responsible for fixing the queries, right? And there'll be imperformant queries, or there'll just be regressions that have been introduced, but only the infra team is really equipped to go and triage all the slow query logs on the database. And
Yeah,
that feels like the similar sort of problem where the feedback loop just isn't there. And the people who end up being
yeah.
responsible for fixing it aren't the people who wrote the code. Yeah, I wonder if that is because project development life cycles just dictate that people don't incrementally ship enough of that to see the feedback loop, or there's just some sort of like organizational problem where infra as a team that deals with this is just malformed, right? It just is not a sensical concept.
Yes, the answer is yes to all those things. I think you see a lot of sort of innovation in the past few years about pulling together product teams that can own the life cycle of what they're building for this reason. But there's also
Mm-hmm.
a reality that our tools have not, the state of the art. I'm always really awkward whenever I talk about things that only Honeycomb can do, because I want to be talking in a very vendor neutral way. And I believe that a couple of years from now, like this will be the way that the industry operates, but there's a bit of a moat. Like people have to change, vendors are going to have to change the way they store things. There's a reality that if you're using tools that are built on top of metrics, and there's two ways that people use the word metric. There's the generic, it's just a synonym for telemetry. And then there's the metric, which is just a
Mm-hmm.
number with some tags appended. And time series databases store no relational data whatsoever. So like when it comes to debugging and understanding your code, like context is what makes data valuable, and metrics have no context. And so that means that if you're a software engineer and you come along and you look at your instrumentation, you're trying to ask questions, the data that you need doesn't exist, which means that the people who are debugging it have to come with this wealth of knowledge of how everything fits together and how high level code translates into low level systems resources. And that's the
Yeah.
only way that debugging has been possible. Like I used to hear engineers complaining a lot that by putting them on call for their code, you are asking them to master two disciplines or do two jobs. And they were
Yeah.
right. Traditional ops dashboards and tools, your Datadog, your Prometheus, they speak to you in the language of, we've got 4 types of system memory and this many CPUs. So you're a
Yeah.
software engineer, you're shipping your diff and you're like, what exactly just happened?
Yeah,
And like
yeah.
the tooling you need to serve to them speaks to them in the language of variables and functions and endpoints so that they can go, it's timing out talking to that API endpoint, or we're getting packets
Hmm.
to there. And so this is not just anytime you're like, it's not working because people are just too lazy to look at their stuff or something, like, it's probably not the right answer. Like the tooling hasn't existed, but also the way that we are structuring our teams hasn't been doing us any favors. So I feel like there's a lot kind of converging right now. I think that Honeycomb sits at the nexus of a bunch of different trends. And I think that this is why, if you look at the DORA metrics year over year, you're starting to see the teams that are doing well are like reaching like escape velocity, and everyone else is getting like worse and worse
Yeah,
over time. And that's
yeah,
because it's hard, and it's all a feedback loop, and it's all very self-reinforcing, but it's not hard. Like, this is the tricky part. It's not hard. It is so much harder. The way teams are doing it now is the hard way. It's
yeah,
so much
yeah,
easier to work in fast feedback loops when you can see the data. But there is a bit of the way through over the mountain is not yet like reducible to sound bites. And so there's a bit of like
yeah.
fighting our way through the forest to get to the promised land. But the promised land is so much easier than the way people are doing the work now.
Yeah, it almost feels like, I think one of the things you said is it almost feels like you're writing two different versions of your business logic. Like you're writing your code and you're writing your function calls or whatever, but then you're having to rederive the importance of the different parts of that code in your observability tooling, and perhaps having to even restate the importance of what should be measured and what shouldn't be measured. So one thing I'm wondering is part of the thesis that observability tooling, or the thing that you go look at in production, should just naturally fall out of your business logic? Like, how much intentionality should you have to put into setting up this other tool? Or should it just be like, great, I wrote my code, everything is like framework level instrumented, and now I can see it in a tool like Honeycomb?
Um, it shouldn't be difficult. So like part of the problem with today's tooling is that it is really hard to instrument your code in a way that will let you understand things, because high cardinality is just, it's prohibitively expensive. So when people say custom metrics,
Yeah,
I've been doing this for 8.5 years, and I just learned this. Well, I always thought when you say custom metrics, Datadog gives you 100 free custom metrics. I'm like, cool. To me, that sounds like 100 lines of code where you inject a metric
right.
with the name of it, right? That's not what custom metrics means. Custom metrics means cardinality. You get 100 free cardinality. And cardinality, for those who don't know, means the number of unique items in a set. If you've got a collection of users and their unique IDs, you've got 1 million users, you've got 1 million cardinality. And there are so many blog posts and talks and everything about how to try to not have cardinality in your data because it's so freaking expensive. But that's just that is a path with like that is a alley that goes nowhere, because you have to have cardinality to understand your data. High cardinality data is the most identifying, the most interesting, I can't even count the number of times that I have solved some weird ass bug just because it admitted a weird ass unique string. If you don't have
Right.
that high cardinality data, you're screwed. You cannot so like I shit talk metrics a lot, and perhaps unfairly, because metrics are not a bad tool, but you have to, when it comes to data, we've learned anything, you have to use the right tool for the job, or your costs are just like out of control. Metrics are a powerful tool for summarizing vast quantities of data and letting you age it out gracefully while like keeping the shape of it and just reducing the granularity. They are not a tool for debugging or understanding your systems. Anytime you need a scalpel,
Hmm.
metrics are not a tool you can reach for. So like part of the sort of paradigm, and yet metrics are what the last 3 decades worth of tools on the market have been built off of. And they're just a technology that's reached its end of life usefulness. Also, for a long time, it made sense that we reached for the metric because the most important thing about our data was how expensive it was to store. RAM was
Yeah,
expensive, disk was expensive, everything was so freaking expensive. So we reached for the metric because it was the smallest thing of any value that we could store. But that's no
yeah,
longer true. Like, storage is cheap. Our attention is costly. And so like anytime, like the number one thing that I'm telling people is If you want to move to a world where you can understand your systems and have observability 2.0 outcomes, take all of this energy and cost you're allocating to trying to get useful stuff out of your metrics stack data and just reallocate it to structured logs. If you do nothing else, just do that. Because that way, like the metrics way, just like madness lies.
Yeah, it's funny. I'm guessing that there's more VPs of finance that know how custom metrics billing works than engineers because,
almost assuredly,
telling their teams.
I wrote a blog post called like the cost crisis in observability tooling earlier this year. And I don't know how many observability engineering teams I heard from in the aftermath of that who like shamefacedly admitted to me they spend an outright majority of their time on cost management. Not adding value to the business, not building libraries, not helping, not even supporting their teammates, actively trying to manage costs, but mostly by watching for unexpected spikes in cardinality and then deleting them. That's all they do. It's a full-time job. The amount of time and energy and money we are sinking into this dying technology is like mind-boggling. So their whole question was about instrumentation, right? And knowing how to instrument your code with metrics it's even for experts. Like to some extent, you just got to put it in and see what goes out because you can't. It can change up from under you if the data changes. Oops, I thought that was going to be low cardinality. Turns out it's high. Over the weekend, it cost me $50,000. Is a not uncommon refrain. You have to think a lot about it. You have to like constantly delete things. It should be so much easier. It should go something like this. As you're writing code, you know how like we all have this sort of meta monitor in our minds? I should add a comment for this. It's going to be challenging someday. We should have this same sort of like meta thread. Just, this might be useful to someday. Toss it in the blob, right? Shopping cart ID, probably useful someday. Toss it in the blob. User ID, probably useful someday. Toss it in the blob. And so like for Honeycomb, we charge by number of events and we encourage you to make them as wide as possible because width means context. If you've got a dimension, if you've got an event that's 300 dimensions wide, awesome. They can all be high cardinality. We don't care, right? The wider the better. 500, 1,000, up to the number of Linux file handles that can be open. Like just toss it in and forget about it. Do not delete that. You don't know what's going to be useful someday. And it's using that one thing that's useful. It's like the conjunction of 5 or 9 or 11 rare things. And that's how you can identify what's wrong, like immediately, because, this thing I care about is different in 12 ways. Cool. Now I know what it is. And you don't get that unless you've just been accumulating things that might be useful someday over a period of time. But no, it shouldn't be hard. You shouldn't be having to think about what's the format, what is the data type? What's the cardinality of this going to be? What about when I ship it to production? What if the size of the fleet grows? Is that going to change the entire model of this thing that I've said? Like all of that is so hard and should not be necessary.
Yeah, it seems like an unfortunate chain of events because not only does create all this work for cost control, but it also means you have to be super intentional when you're first writing the code to know what you're going to care about. Yeah. So actually, it's a good segue. Let's talk a little bit about that honeycomb architecture and system, because I think a lot of engineers, especially if you're coming from an OLTP database, you're like, oh, that must be really expensive. I can't store all these columns because I'm going to does honeycomb have to index over all of them? And so maybe there's this kind of intuitive concern of, I need to conserve the width of my event. So, talk a little bit about the column store you've built and how you're able to effectively query over all this data.
This is the beauty and the pain of data, right? Is that when you find the right data model, problems that were previously like intractable, just like incomprehensible, can become just like so easy and so fast. The speed is one of the most important things about Honeycomb. We have an SLO for ourselves. I think the 95th percentile of queries needs to be under a second. It's absurdly low. We'll often have the experience of you're writing code, you're instrumenting, and as soon as you, not even deploy, but as soon as you like issue an API request, as soon as you change over to the browser and look for it, like it's there. It's so fast. And we start to take that for granted and then we go use some other tool and we're like, oh my God, it takes minutes to show up. What is going on here? But I think that's so important because you need to be asking questions in a state of flow, right? Anything that stops you is going to break your concentration. So Christine and I had worked at Facebook and we used the tool there called Scuba. And there's a white paper out there on how Scuba was built. And that was the genesis of Honeycomb. And it's a distributed column store. In column stores, it's the opposite opposite of a relational row-based database, right? Where you have to everything's stored as rows, and you have to build indexes. In a column store, everything is an index. And that's just how it is. In the early days of Honeycomb, we stored the data on SSDs, but we pretty quickly ran into exactly the kind of cost problems that you would imagine when data is stored constantly and accessed rarely. We're like, this is not going to be financially feasible for us for a very long time. And at that point, we serverlessed our database. One of our engineers, Ian Welts, who was actually my first engineering manager when I was 22, developed our early data store. And so when an event hits our API, it gets dropped into Kafka immediately. And then we have pairs of retriever databases that pull the events out of Kafka. So it gets stored in SSDs for a short amount of time, but then it very quickly gets aged out to S3 buckets. And our query engine is actually runs in Lambda jobs. So when you issue a query, it kicks off a Lambda job, which goes and fans out, pulls the data down from likely hundreds or thousands of S3 buckets, and then merges it and returns it to you in under a second. So it definitely scales. We run on the order of tens of millions of writes per second. We have many hundreds of customers, and we effectively run the combined production load of them all. It's quite large, quite scalable.
Yeah. And I just want to highlight how different that approach is from something like a streaming aggregation approach, where you're aggregating the data for a specific set of percentiles or distributions that you've pre-configured in stream. You're actually querying over the data in S3.
Yes, this difference between write time aggregation and read time aggregation is part of the secret sauce. Anytime you're aggregating at write time, you're effectively locking yourselves in to being able to ask only the questions that you predicted up front that you might want to be able to ask, right? You're like, okay, I might want to ask what the 99th percentile is, what the max. You're saying future me is only going to care about these questions, which is what you do with metrics, right? And part of the Honeycomb model is we store the raw events, and you can ask any question you want of them, which means we do all of that aggregation at read time. So you can ask, you can slice and dice and combine and recombine. You can zoom in, you can zoom out, you can go up to SLOs, you can go all the way down to raw. You can combine every individual raw request against each other, and which is such a paradigm shift. People don't realize how bad they have it because they don't know how good it could be, which to me is a little ironic because, on the business side of the house, they've had nice things for years. You could not run a business without the ability to slice and dice and ask arbitrary questions of your business data. And yet on the systems side, we've just been over here living off starvation rations. We can't pay for wide event. We can't pay for structured logs. Let's just serve ourselves metric. It's classic, the cobbler's children have no shoes, which honestly is another part of this that I think is really interesting, which is that my friend Austin, who works with this, has often said, if all that Observability 2.0 does is give us a better, faster monitoring system, it will have failed, because a huge part of making this data valuable is incorporating the business context. All of the really interesting questions you ever want to ask are some combination of system, application, user, and business requirements, right? And having those siloed off into different teams and different tools just contributes to the dark matter of software engineering, just this difficulty with reconciling your views of reality before you can even ask or answer the interesting questions.
Yeah, that makes a lot of sense. And I don't know how much you all have thought about the economics of this internally recently, but I'm curious, have things like S3 Express One Zone changed the model at all for your customers? Because that kind of lets you swap out a faster storage layer for really no architecture change. Is that something that people have asked for or you've thought about much?
I haven't thought about it much. I haven't heard anything from the engineering team. Maybe they have, but I don't think so.
Interesting, yeah, because I'm just wondering, maybe that's not a bottleneck at all. If your P95 is still less than 1 second, maybe that's the storage layer is not.
That actually really surprised us. We approached that as an experiment. We were like, there's no way that S3 is going to be fast enough to meet the kind of needs that we need. No way. And to our shock, it actually was, because it's parallelizable enough. And also just because it didn't have exactly the same performance characteristics as the S3 disks did. As the SSDs did. But some of the things that were faster were slower, and some of the things that were slower were faster. And so all in all, it was a wash.
Yeah, and imagine you have to think carefully about things like the sizes of the files that you're writing so that you tune the parallelization factor.
Yeah.
There's, I imagine, some pretty serious innovation in the actual storage format to
Yeah.
S3 and maybe the caching in front of it. One thing I'm wondering about is you all have, in addition to thinking about the storage layer and the query layer, you've also started introducing things like bubble up, right? With this idea
Hmm.
of surfacing, I don't know if you would call it categorically AI, and so I'm curious how you would describe it, but surfacing outliers and insight. How do you think about that in kind of relation to the workflows people use Honeycomb for?
I would not call it AI. I would call it straight up computing. So
Okay.
bubble up, for those who don't know, is just any graph that you draw in Honeycomb. You can draw a little bubble around any part. If you're like, this is interesting, I want to understand it, or this looks like an outlier, this is a spike, whatever. Draw a little bubble around it, and we instantly pre-compute, or we compute for all of the dimensions inside the bubble versus outside in the baseline, and then we sort and diff them. So you're like, I care about this, and then immediately you're like, the thing I care about is different in XYZ ways.
Yeah.
And that is possible because we store so much context, so we can just compute it. I actually think that all of the quote unquote AI innovation in this space is a hack around the fact that people are not storing the context and can't compute it, so they have to guess about
Yeah.
it. And it does
Yeah.
not seem very effective to me, honestly. There are some great uses for AI, but they're all in non-deterministic stuff. When it comes to deterministic relational data, you actually just want to calculate things. But if you
Yeah.
haven't been storing those relational things all along, you can't calculate the things. And I think it's a little bit cynical, and I have not heard any good things about anyone about how well it works.
Yeah, it sounds like you're saying AI is a like interpolation technique, but if you can just store all the data, you should store all the data and you should be able to query over it effectively, right?
I want to say there are some really interesting things we can do with AI in this space. We actually have an AI feature that's called Query Assistant. So you can just ask questions of your data using natural language. I just shipped something. What are the slowest endpoints? What changed? Which is dope.
Yeah.
And I think that most of the really promising areas for AI are those sort of fuzzy, non-deterministic, like mostly in the realm of how are my
Mm.
humans interacting with this system? And then how can we use that sort of synthesize and bring everyone up to the level of the best debugger in every corner? Because while you're
Mm.
developing on a part of the system, you know that part intimately, but when it comes to understanding the system, you have to understand the whole thing. So if we could be like, how can we like everyone is expert at interacting with their part of the system, so how can we bring that wisdom together for everyone? I think that's really interesting. But the simple
Yeah.
stuff about I just shipped a change, what happened? You should not need AI to tell you that.
Yeah. Yeah. Yeah, I really like that. It sounds like what you're saying is that you want to lower the barrier to entry for people to interact with the tool with AI, and that could be things like natural language querying. But for the precise things where you're
Yeah,
looking for something, that's maybe not a place for AI.
the place for AI.
And
False
and
positives are
actually,
so
yeah.
expensive.
Yeah, exactly. That makes sense. And actually, that's related to this. We've talked about the architecture of Honeycomb. It would be, I think, useful context to talk about the kind of data model of Honeycomb. Notably, not these kind of three pillars, but what does it look like for someone to use Honeycomb in the sense of the workflow in the product? If it's not just, oh, I'm having to flip back between traces and metrics and logs and try to manually connect the dots.
Oh, that's such a great question. Yeah, when you're debugging with three pillars, it does look a lot of, okay, I'm getting paged, I'm jumping to my dashboard. I'm going to start like flipping through dashboards, looking for other shapes like that shape. And then when I find something I think might be it, I'm going to jump to my logging tool and look for the same time range and start looking for strings that I know. Like you have to know what you're looking for in order to find it. And then you have to jump around from tool to tool. And with Honeycomb, it's much more like, typically you get paged because of an SLO gets burning down. So you jump to the SLO page.
Yeah.
The SLO is burning down. You see exactly why it's burning down. You see how the events that are violating the SLO are different from the events that are not violating the SLO. You might click on the top one and you'll go to a graph of it and you can be like, show me this over time. It's absurdly simple because, and yet it's hard to describe because it's not like you do bus. You look at the data tells you what to
Yeah.
look at next. And then you look at the next thing and typically within a few seconds, you found it. We have this experience over and over again when we're doing a POC or a trial with a prospective customer where we'll be pairing with them, instrumenting or something, and we'll be like, what's that? And they'll be like, what's what? And then 5 minutes later, they'll start to have an outage or something. And we're like, oh, well, it's right there. Or another thing that happens a lot is we start looking at it and we'll find things. We're like, oh, what's happening here? And they're like, oh, shit. And then they're like, oh, we got to go fix that. And we're like, I hear you, but this has been like this for God knows how long. And if we stop to fix everything we're going to find, we're never going to get this rolled out and instrumented. Because like people's aggregates like are covering over a multitude of sins, right? There are so many things broken in your system right now you just don't know about because your data doesn't surface it to you until a customer complains, and then you go waste a day or two trying to repro it. But like when you have the ability to just see the outliers in your data, like suddenly so many things become so obvious to you.
Yeah. So is it right to think that in the honeycomb thesis or way of doing things, a lot of your intentionality is going into the definition of the SLOs? And I almost feel like that makes sense from a macro business perspective.
Absolutely.
Is that right? Okay.
Absolutely. A big part of the shift from Ollie 1.0 to 2.0 is often around that sort of entry point, that what you're getting alerted for, what you're getting paged for, right? Because in the battle days, we were like, anytime a symptom looks like it's spiking, let's alert someone and wake them up in the middle of the night, which doesn't scale, right? And it burns people out really fast. And so you want to shift to SLOs so that you're aligning engineering pain with customer pain. You don't want to try and wake someone up because something might be about to go wrong. You want to wake someone up when customers are in pain. And that's it. So you put in the work to define these SLOs. You're like, these are the things that our business is built on. There are lots of things that can happen that someone should get to eventually, but these are the things that our customers will notice and feel that will hurt us as a business. And once we all agree on those things, like I think of SLOs as like the APIs for engineering teams, because in the absence of these SLOs and agreements, you're all getting up in each other's business about your roadmaps, right? You're micromanaging. You're like, but I want to get on your roadmap there. If we make these agreements, then I agree to provide this level of service. What I do on the other side of that is my fucking business. So I think that's a lot of the really important work around this is defining SLOs.
And it sounds like that would be the right bridge between the engineering team and maybe the like VPs and directors, which is, okay, what are we getting out of this migration to a tool like Honeycomb, like adapting this new style of thinking? It's okay, maybe we're getting these SLOs defined for the first time ever, right? We're actually understanding what the contract of our service is.
Yes, 100%. I think that's really meaningful. I think that's really insightful. I think that the other thing that the companies that Honeycomb seems to be really successful at this point, like there are two things we really look for. Number one is, does the company have dollar values attached to individual requests? Delivery companies, finance, if they know that their outcomes, their specific outcomes, like lead to changes in money up or down, then they're probably really good Honeycomb customers. Versus like ad companies that are just spray and pray. Like they don't give a shit if an individual ad makes it to an individual eyeball. Not a great Honeycomb customer. And the second thing that predicts a really good Honeycomb customer is a certain level of intentionality. Sometimes we get great customers who are like firefighting all day long, but more typically it's companies that have gotten themselves out of the weeds a bit such that they're able to plan for the next couple of years. They're like looking at what's coming down the pipeline, and those make great Honeycomb customers. A lot of them are at the tip of the iceberg of the platform engineering sort of changes, where they're devoting teams of engineers not to owning production directly, but to empowering engineers to own theirs directly. Those are great Honeycomb customers and ultimately we want to become a great vendor for the teams that are the bottom 50% of engineering teams. But right now, we're a very small team relative to our competitors. And the ones that make really good Honeycomb customers are the ones that are really like anticipating the future and trying to build the right sort of human socio-technical architecture to solve future business problems.
Yeah, and it's frustrating because it's really hard to imagine being able to pop your head out and think about the future when you're spending so much of your time on things like cost control. So it's like you need that stuff to be able to do it, which is tricky.
It's a whole chicken and egg thing. Yeah.
Yeah. Maybe last question. What are you most excited about that Honeycomb's working on now? Or it could be just like industry-wide. What do you think is working in terms of the way you're trying to push forward the conversation?
I'm really excited about OpenTelemetry. The goal of OpenTelemetry, it's got a bit of a reputation, much like Kubernetes, for being overkill, like a big kind of bulky. But I'm not going to argue with any of that. But the beautiful thing that OTel does is make it so you instrument your code once. And then you can make vendors compete for your business based on how awesome they are, not on locking you in to their custom instrumentation crap. I'm really excited that project has really achieved liftoff and people are getting on board. It's in a good place. I'm also really excited. Honeycomb, we're building front end observability, connecting the front. You should be able to trace all the way from your device to the back end and back without breaking. I feel like the edges of tools are what creates silos way too often. Is like you've got your view of reality because you use this tool. I've got mine because I use that tool. And so knitting everyone together into a single engineering org with a single source of truth is really exciting to me.
Yeah, awesome. I'm both excited for less vendor lock-in, I think, industry-wide, but also really excited about all the conversations you're spearheading throughout the industry. So really great having you in this conversation and on the podcast, and appreciate your time. Thank you.
Thank you so much for having me. I'm glad we managed to make this work.